Welcome student. We are on the module 6 of CMA final paper number 16 study notes. Paper number 16 name is strategy cost management, and we are discussing linear programming problems of module 6. In this my first class, I have already explained the basic concepts of the linear programming, the conceptual framework, and also describe and explain illustration number 1, which was basically maximization of profit. So as I earlier explained in previous class, linear programming is a decision making technique where we have some objective called objective function. This could be maximization of profit or values, or minimization of the cost, where we have some limited resource or resource that have some alternative use. So fulfilling all these constraints, we have to optimize our objective function, right? So this illustration is basically this kind of this minimization of the cost. uh, second second thing, that minimization of the cost, that we understand it. I'm reading this very carefully. You listen, please. A dealer of cement has two warehouses, namely M and N, with the stock of 30,000, 20,000 bag of cement respectively. So this is the basically supply, right? This is the supply available with the dealer at two different warehouses. Three customers, namely A, B, and C, have placed order on the dealer for 15,000, 20,000, and 15,000 bags respectively. Cost of the transportation per thousand bag. Here, this please this note this point. This is the basically this 100 sorry 1,000 per bag of the cement from the different warehouses to different customer. This given in the tabulated form. So here we have to carefully see these two figures. This is the per thousand of bag, and here is the cost is rupees in 100, rupees in 100 per thousand bag. So this will be used in later stage. So just I am highlighting these 2 points, right? Cost is the rupees in 100 and bags are in 1,000, right, sir? So this is the basically supply side, and these are the demand center. The dealer want to find how to fulfill the order so that the transportation cost is minimum. As I earlier said, you don't go into theory much detail. Whenever the things will come in the question, I will explain already uh, something, and I will explain as and when they comes in the question. So transportation cost is minimum, as already this is the objective function basically. So in the linear programming we have three kind of thing. One is the objective function, second is some constraint, and the decision variable, right? So this is the objective function. Our objective is to minimize the transportation cost and formulate the formulate the problem. So formulate problem means we have to mathematically establish the equation uh, of these all story, right? Okay. Supply is M and N. Supply is at M and N only, and demand is at centers A, B, and C respectively. So here we have 30,000 bag available, right? Or here we have 20,000 bags available, and the demand is at this center is 15,000. Here on B is 20,000 and C is again 15,000, right? So and again we have some cost uh, associated with supplying from this location to these centers. So for better understanding or to make our calculation simple, we assume that this 1 unit is equal to, assume that 1 unit is equal to 1000 bags. ठीक है? Okay. So effective demand at this center is 15 only in term of unit, 20 only, and similarly on 15 only, right? At the location C15 only, and accordingly assume that this is the 30 and 20 unit available at warehouses M and N, right? So suppose suppose M center supply to A, say X1 quantity, right? So here X1 quantity we have this assumed variable. This is called the decision variable. Suppose M is supplying to A X1 quantity and X2 quantity to B. So remaining the requirement of C is the 15 only, right? The requirement of the C is 15 only, right? But how much it can supply to C, sorry, it can supply only because it has only 30 units available. X1 supplied to A, X2 supplied to B, so it can supply only 30 minus X1 minus X2, right? Actually there is some problem, so I'm writing here like minus X1 minus X2. Again come this center A has the requirement of 15 15 unit only, out of which X1 already supplied by the M center. Now to fulfill the requirement, center N, how much it should be supplied? It should supply only 15 minus X1. Okay, so this 15 unit will be fulfilled. Accordingly, we already uh, has X2 unit from which is supplied from the center M. So N can supply this uh, 20 minus X2 so that it will fulfill the requirement of 20 units, right? Similarly on the C, as you know, this already the requirement is 15 unit only, right? And this 30 minus X1 minus X2 units are supplied by center M. So remaining how much N can supply so that this 15 unit requirement is fulfilled? 15, 15 is the requirement, out of which already 30 minus X1 minus X2 is already supplied. So what it will be? It will be this X1 plus X2 minus 15, right? So this is the basically the structure we have created for this supply and demand pattern. One more point here, you see this is the, and we should actually earlier check this point. So what exactly the supply available is the 50 unit, right? Total is the 50 unit. This is the supply available, and the demand is 15 plus 20 plus 50. So this is the sum is again 50. So this is the balance problem, right? Already our supply and demand are same. So this is the basically these are the decision variable x1 and x2 are the decision variables, and we have in fact in tabulated form we have distributed this supply and demand, right? So the people have already written like this only, okay, as the transportation cost of bag is like this and like this. The basically language they have written, but I already explained the tabulated form. So this the you understand this the cost is transportation of per thousand bag is 40 100 40 this per 100 na, so this the cost effective will be 4000 only. So based on that table which I had earlier created, we will have this transportation problem formulation like this, right? Just I am explaining, please wait. This the our uh, the objective function is 4000 because we have assumed x1 unit as a per thousand bag. So 4000 is the cost of supplying cement bag per thousand unit, right? So 4000 x1, 200 2000 x2, and 2030 minus x1 minus x2. You already I think got that from that table because I'm just again writing like this. This our problem like this m1 m and n. See, this was exactly 30 unit available here and 20 here. Demand is basically I'm again writing it, right? 15, 20 and 50. So how we calculate is that x1 and x2 we are supplying, so this will 30 minus x1 minus x2, right? And again this the again we from n center 15 minus x1 and 20 minus x2, and finally we have calculated this x1 plus x2 minus 15, right? So we have associated this table which I already explained to you, this table to this see 4000 I have already explained why it is 4000 coming. So 4000 into x1, right? 2000 into x2, 2000 into this c1 remaining the variable is available here, 30 minus x1 minus x2 plus 2000 into 15 minus x, 6000 into 20 minus x2, and the 4000 into x1 plus x2 minus 15. So these are the basically cost table, right? Already given in the illustration, right? So accordingly, when we solve this whole function, this whole equation, we will get this z is the objective function, that the minimization of our transportation cost is 4000 x1 minus 2000 x2 plus this 1 lakh 50,000. So this is our uh, this the objective, this the our this maximization of minimization of transportation cost equation. As the problem deal with the unit of the bag cement, each of the unit mentioned above should be a non-negative, right? Because all these are the physical units. So decision variable could be x1 is greater than equal to 0, x2 is greater than equal to 0. Third one is also 30 minus x1 minus x2 is greater than or equal to 0, or we can solve like this: x1 plus x2 is less than equal to 30. We have just inverted it. Second is 15 minus x1 is greater than equal to 0. X1 or we can write like this: x1 is less than 15, right, by changing this sign only. Again 20 minus x2 is greater than equal to 0, or we can write it like this: x2 minus x2 is less than or equal to 20. And third one is x1 plus x2 minus 15 greater than equal to 0, or x1 plus x2 is greater than equal to 15, right? So thus the mathematical formulation will be like this only: minimize z 4000 x1 minus 2000 x2 plus 1,50,000 subject to constraint. ठीक है, तो these are the constraint. First constraint is already x1 plus x2 is less than 30, right? This one, x1 plus x2 is greater than equal to 15, x1 is less than equal to 15, and last x1 is less than equal to 15, x2 is less than equal to 20, and x1 and x2 are greater than or equal to 0. So again we have discussed the term like objective function, constraint, decision variable. So this was our the minimization problem.